we're back. Just a quick note, we did swap producers. So if you were watching, you may have noticed a little blip there where we went offline temporarily. But we're back. I'm back. Nice to see everyone. Thanks for hanging out. I am here with Helen. And Helen, you're going to take us through Kubernetes 101, which absolutely makes me laugh because I keep getting pulled into Kubernetes and Knative sessions. It's like your team and your people want me to learn this.
Yes, definitely. So I'll just introduce myself. I am Helen Lam. I work as a developer advocate at IBM. And last week, Amara sent an email. And so to celebrate International Women's Day, we wanted to do a Twitch session. And I decided to challenge myself greatly in 1 week. So I decided that I would run through the first parts of the Kubernetes 101 lab. And I've been meaning to get around to this because, as a developer, particularly as a developer advocate, you really have to stay on top of the newest technology. And I'm coming from a Cloud Foundry background, and Cloud Foundry is pretty simple in terms of deploying applications. A lot of the infrastructure is abstracted away from you. And it's kind of intimidating when you first take a look at Kubernetes, and there's a lot of concepts you need to know. And for myself, given the time constraint, I just wanted to sort of run through and deploy a very simple application and then run through that with you guys as well. And so pretty much if I can do it and I've learned in a short amount of time and the instructions are very clear here, then you guys can do it too.
Awesome.
Yeah. Also, I don't have any slides. The best way to get a hold of me is on Twitter. So if you just direct message me or tweet to me, if you have any questions. My background, I normally specialize in Watson APIs. I've also started to expand into some of the blockchain stuff at IBM. And if I can't answer your question, there will be someone else on my team that I can refer you to. So yeah. So I'm just gonna go through, if you go to this web page on github.com/IBM/Cube101. So we have half an hour, and if you go to the workshop component, we have a total of, I guess, 5 labs, and we're going to go through some of the setup instructions, lab 0, and then lab 1, where we're going to deploy a really simple application called Guestbook. My computer is making a really loud noise. I hope it doesn't crash.
I'm thinking really hard.
Okay, great. Okay, so first thing when you get started is that you do have to register for IBM Cloud. And then the second component, so if you actually go here, so install the IBM Cloud CLI, and you can sign up in this corner. And so anyone can sign up. You don't need a credit card. You automatically, when you get started, you'll be given 4 free services. So database is a service, 1 Kubernetes cluster is a service. So you can really use this free account to explore any APIs. You might have to delete old applications that you're not using, but it's really great for just a sandbox environment. And so here, okay, you would just have to install the command line interface. I'm not going to install it, but I'll show you how to log in from the CLI. Sorry if my screen's a little bit slow. It is lagging because we're streaming a little bit. Okay. Okay, so I have 3 accounts I work in the client developer advocacy team, so I have a third account called POC. And then we have this wonderful shared account with 100 or 200 other developer advocates. So
yeah, if you were just creating your account and you weren't involved in all these teams, you would just have one to log into. You wouldn't see multiple, right?
Exactly. So here, okay, I have logged in, and okay, I'd like to install the IBM Cloud Container Service plugin. So you absolutely need to install this in order to interact with all of the Kubernetes containers within the IBM Cloud environment. So I'm going to run that. And so I'm not going to reinstall it. So I'm going to say no, but that's just to show you. So to make it feel less intimidating when after we finish this session and you want to learn more about Kubernetes, you can go through it. And so, okay, so let's just run the plugin list and we should be able to see container service. Okay. A little bit small. Is that better? Is that good?
Okay. All right.
Can you guys see my desktop? Google Chrome. And then here, you're just going to download the Kubernetes CLI. So I have a MacBook. So I click here, and then you'd have to move the executable file. So right here, if you're on a MacBook, usually goes to your downloads folder. So here you would just replace this with downloads, capital D. And then you would run this command as well, and then convert the binary file to an executable. Okay, and then the last part, and this is really simple, is just git cloning the guestbook, which you'll need for lab 1. And then later on, maybe in a future Twitch session, I can go over lab 2 and 3, and then that's a second application. So let's go to move over to lab 1 and deploy this guest app. If you guys get stuck in the setup, feel free to message me on Twitter. I can release my email if you'd like to talk further and share screenshots. Okay. Amara, do we have anything like on Slack to communicate, or is it just mainly on Twitch where we can message?
So if anybody has a question right now, I would recommend the Twitch chat. I usually tell folks to go to developer.ibm.com, and then down in the footer, we have something called answers. And I typically send people there because it's like a Q&A forum that a number of folks watch. So down at the footer in the right most column. Yeah, that one. So people, it's basically like our Stack Overflow. I think it was originally part of Developer Works and kind of their forum, but you can tag things with different technologies. I've noticed advocates in there, folks from the products teams, our offering managers, a ton of different folks in there answering questions, which is super helpful because I'm not always available and I'm not always as fast as 20 other people at IBM that probably can answer it too. So that might be a good place, just so that people aren't coming to like you specifically and you get busy.
Definitely. Feel free to troll me. So part of my agreement is, I teach in not I'm gonna say in real life, Amara, but I normally teach in an environment where I'm physically in front of you. And
right.
So this is my first time teaching on Twitch, and
it's a little different.
A little different, but I feel obliged to be there for my students. So direct message me and I'll try to find the answer for you if I don't know it myself. or tweet at me. But direct message is better. It's just a little more private. Okay, so we already completed the steps in lab 0. And now we have to provision a cluster. So because I've run out of free services, I'm actually going to show you how to provision a cluster through the GUI. And honestly, it's super easy. So I would actually do this myself if I were you. IBM Cloud is no longer called Bluemix, but our URL is still Bluemix. So here, okay, whenever you're looking for any service, super simple. You just need to go to catalog and type up whatever you're looking for. Kubernetes is so popular that I don't even need to look for it. It's right there. And here, okay, all these different features, gives you different pricing plans. I'm going to scroll to the bottom, click on create. So you would click on free, okay? So there's no cost. However, I have to click on standard, and then also I'd like to show you the different options you could select. So under standard, always going to pick the default, and I am in North America. I'm in New York City right now, so I'd like my application to be hosted here. I'm going to pick multi-zone. So within each data center, there's 2 here listed, Dallas and DC. I'm going to pick on DC, and I would like 3 worker zones. It's probably not necessary. And I will delete this, Mike, afterwards.
It's like your stream producer is the guy who watches these things, right? And just a quick comment about the Bluemix URL. So we do have cloud.ibm.com. It's also live. I think they're both live. It's very kind of strange right now. They both go to the same place or almost the same place. It may like force you to log back in again, but you can keep going on Bluemix. I think they're like slightly different dashboard views at this point.
Wow. Okay, interesting. Okay, and then so I picked 3 worker zones, and now we're looking at, okay, worker pools, configure a set of worker nodes. You can update your pool later. Okay, and then so already did that. And I always go for a stable. So it's not the latest version, but it's the most stable version. So I would go with that. And here you can actually select if you'd like your cluster on a bare metal server, in a shared VM, or in a dedicated VM. And I'd like 16 gigabytes of RAM and 4 cores. I like to keep the default of encrypting with a local disk. And so I have 9 workers total. So if you look up here, so I have 3 worker nodes within each worker zone, so a total of 9. Okay, so I'm gonna create the cluster. Okay, my laptop's making a really loud noise again. Fan. Amar, are you streaming? You're streaming on Twitch, or Mike is like who's on Zoom and on Twitch?
So we're both on Zoom, and then Mike is using his computer to push things out to Twitch. Because oddly enough, we could definitely kill your computer very quickly if we had you running OBS and Chrome and Slack and all of these other things at once, trying to get the stream up yourself. So this is kind of our like hacky way to do it, but sometimes it does make computers cry.
Right. Awesome. Okay, so it takes a while to provision. So here you can see that it's my cluster has been requested across those 3 worker zones in DC. And here, so there's a little bit of overlap with the instructions. So I believe I already did this in lab 0, but I just ran it in the command line, didn't like it, and then we can log in here. I'm also already logged in. So I'm actually going to use the cluster that I already created, because this can take up to 10 minutes for the one that I just deployed. Oh, that would be US South. Oh, you know what? I'm going to do single sign-on. So if you have SSO, just do this. I already signed in. That's okay. Let's copy. Okay, so go back to, oh, I don't like that bar at the top. It's kind of in the way.
It keeps bouncing down, yeah.
There's no way to get it to go back. Okay, fine, I got my tab. Okay, okay, so then target the Kubernetes service region in which you want to work. Okay. Okay, and so there's US East and US South. So I'm typing in South because I'm going to use the Kubernetes cluster that I deployed yesterday, and just redeploy the guestbook application. I already deleted it. And here, okay, so I need to enter the name of the cluster that I created yesterday. I will never again create such a long name for a cluster. I have to write that down before I join Twitch. Okay, so here we want to set the environment variables, and we're looking to get this. So because I ran this yesterday, I tried this earlier just before I joined for the past 2 hours. And so I'm actually going to scroll up and show you guys. I'm going to expand it, Mike. It's hard for me to take a look at this way. So here, okay, so this is what it should look like. So when you run that command, IBM Cloud KS cluster config, and then the name of your cluster, and don't pick something long like me. So the configuration for Helen Lamb cluster was downloaded successfully. Export environment variable to start using Kubernetes. So the yellow, what you're going to do is just copy and paste the yellow. Okay. It's a .yaml file. And let's, okay, so it's there. Then also, I pulled this up just to show you guys. And so this is the .yaml file. And I'm not going to leave it linking for too long because there's stuff that's private just for my Kubernetes cluster. And then now, okay, verify that you can connect to your cluster by listing your worker nodes. So kubectl, get nodes. Okay, so I have 9 here because I have the 3 worker zones, and with each worker zone, you have 3 worker nodes. Okay, so we're done the setup, and the rest should be easy. believe it or not, that's actually, I think the biggest hurdle was the setup, and then provisioning the cluster, and then setting up the environment variable.
Okay.
Sorry, what?
No, I was saying, okay, that if that's the hardest part, then everything else should be much easier, right?
Right. I noticed I look super red. Do I look red to you guys, or pink? Or okay.
Like I'm always kind of reddish, so.
Okay, so deploy your application. Okay, so we have this guest book application, and we had already, I Git cloned it, that was part of Lab 0. So start by running guest book. Okay. Guest book created. Wow, that was very fast. And let's see. So when I first ran this, I was confused. I thought it had deployed because it said guest book created, and I was like, wow, that was instantaneous. So that's not the case. So it could still be creating and like provisioning the container, and it's actually running. Okay, so it's probably because of the fact that I provisioned 3 worker zones. So maybe it's faster, but even in the free model, it shouldn't take too long. Okay, so we know that it is running. And now we need to expose that deployment as a service so we can access it through the IP of the worker nodes. Okay, so guestbook application, whoever wrote it, but it listens on port 3000. So let's run this. Service guestbook expose, which is the answer that we want. Okay, so to find the port used on that worker node, examine renew service. So kubectl get service guestbook. Okay, so this is critical. I'm looking for this port, node port. So I'm going to write that down. It's 30138. Okay. Okay, so guestbook is now running on your cluster and exposed to the internet. We just need to find where it is accessible. So this tutorial needs to be edited, but this is the name of the cluster of the person that wrote this tutorial. So you need to run this and insert the name of yours. So, okay, mine was super long one. I'm always, because we use a shared IBM cloud environment, I always name mine Helen Lam, blah, 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 don't delete.
That's smart. Yeah, I do the same thing. I'm like, this is mine.
But do you write don't delete?
Sometimes I've done that before where I'm like, this is very important. Like you can delete anything else, just don't touch this one.
Oh no, wait, hold on. Let's see what happened. Error response from server. Specified cluster could not be found. I mean, yeah, you're right. Q cluster.
See, now what's funny is I don't know if the stream can hear Mike, but we can hear Mike. So Mike is like the voice of God who recommended it might be case sensitive.
Yeah. Mike is a Kubernetes expert. Mike, you're right. So for all the, okay, I'm admittedly not always extremely detailed oriented. So it's very important when you're programming to make sure that, you know, do pay attention to uppercase or lowercase. So now I have 9 different public IP addresses. So we ignore the everything else in the private IP addresses. And here we go to the browser and then go to that IP address and put in my node port, which is 30138. Yay! Okay.
There you go.
Guestbook. So let's type my name. and Amara. And what's Mike's last name?
Peterson, yeah.
And then let's write Friday. Okay. So I have achieved my goal with you guys, which is completing lab 0 and lab 1 and making sure that it works. So I did this last night and I was super stressed. But I honestly, Kubernetes, I know it can be very intimidating, but I would start small, just like any kind of goal in life. And it's been, I don't know, Kubernetes is really interesting because you can pretty much code in any language and any framework and be able to deploy it. And I remember when I was using Cloud Foundry, that was a bit of a problem, where you had to have the specific build pack in order to deploy using that runtime. And so Kubernetes is really flexible. You don't have to be, you know, a DevOps engineer with 10 years of experience. You know, you can run through this tutorial and deploy simple application. And yeah.
Hey, that's super cool. And I know you said you were nervous and you were kind of worried about doing all of this in 30 minutes. But I think for the audience, the best takeaway is you did all of this in 30 minutes and you were nervous. Like, so even if someone's sitting at home and they feel like they're very frustrated, they feel like they're very overwhelmed with the technology, as you mentioned, this guide is really well written. It's pretty easy to follow and you can get up and running quickly.
So I would not follow something. I actually have these written down. So whenever I do my own workshops, because oftentimes the documentation needs to be updated monthly or at least every 3 months. And so I was preparing to write my own documentation and then just reference it. But this was pretty accurate. And they have the offering management team and other people. This is actually one of our developer advocates has kept this up to date. And I know there's probably going to be questions. I had questions on like how to horizontally scale your application. Obviously in a production environment, people don't just deploy one pod or one instance of their application. And so lab 2, 3, and 4 goes over that. So I'm looking forward to, you know, going through this myself and sharing with you guys live in my next session on Kubernetes.
Awesome.
So, yeah. And
I'm looking around just to make sure we don't have any questions anywhere. And I don't see any. And sorry, I cut you off. What were you saying?
I was just saying, hopefully I can, I was just going to mention my Twitter handle if anyone wants to contact me. How do I get rid of this? Here. Yeah. So, cool.
Awesome. Did you have anything else to share?
No, nothing other than enjoy your weekend and always challenge yourself. If someone asks you to join a live stream, do it and set goals.
Absolutely. Be adventurous, take risks.
Yes, definitely.
Awesome. Well, we are going to wrap up here, and I believe Maureen is next, and we have a couple more women after that. But Helen, thanks for joining me today.
I know, we have to catch up.
Absolutely.
You're an amazing host, Amara.
Thanks. All right, we'll be right back.
Okay.
Okay, great. Thanks for having me, everyone. I'm excited to be here for our wonderful celebrating our developer advocacy, our Women of Developer Advocacy here at IBM. Today, I am going to be presenting about bias in machine learning and talking about this issue as we've seen it in the news and how this affects us and how we can hopefully mitigate bias and remove it from our data sets. So just to introduce myself, my name is Maureen Mack. As you know, I'm a developer advocate here at IBM. I work on the Center for Open Source Data and AI Technologies, and you can find me on Twitter. My handle here is here in the Twitch stream, but it's Mo_Mack. And let's jump into it. Today, as I said, we'll be discussing bias and how it can take root in machine learning algorithms and ways to overcome it. And as we know, machine learning algorithms are making a lot of decisions for us these days. It determines who's getting a job interview, whether or not your credit score will be raised or your limit on your credit card will be raised, who gets into a clinical trial, whether or not you get a bonus at work. And so, machine learning algorithms are making a lot of decisions for us, and some decisions are much more impactful than others in terms of what is happening, because machine learning algorithms are also determining who goes to jail and who gets set free. And that is something that truly has a sometimes devastating impact on your life. And so we want to make sure we get these decisions right. So before I get into the nitty-gritty, I wanted to talk a little bit, because the title of my talk is Cognitive Bias in Machine Learning. And I don't want to assume that everyone knows what cognitive bias means. So really, in a nutshell, a cognitive bias is a deviation from reality and judgment. Basically, you create your own reality through your perception of something. And, machine learning isn't immune to this very human state. A cognitive bias in machine learning is the existence of an irrational bias in the output of your models. So all machine learning models are trained to discriminate. They're trained to make decisions and determine whether one thing is more important than another based on some parameters. And so we want that. We want it to be doing that. But all too often, AI is trained using biased data and thus reproduces inequalities that already exist in our lives. And you may have seen this recently. A newly elected official, Representative Alexandria Ocasio-Cortez, who lives in New York, made a point in a discussion at a Martin Luther King Jr. rally. She said, algorithms are still made by human beings, and those algorithms are pegged to basic human assumptions. They're just automated assumptions. And if you don't fix the bias, then you're just automating the bias. And there was a lot of backlash to this statement from Alexandria. A lot of people thought that she was being, outrageous, that she didn't understand math, that she was, just outright wrong. And a lot of it was politically motivated, but the reality is that she was telling the truth. Regardless of your political leaning or your political background, we need to make sure that we get this right, because it's really making a huge impact on society. So I'm going to go through some examples of bias in machine learning that we've seen and are pretty well known. In July 2016, Google announced the public beta launch of a new machine learning application program interface called the Cloud Natural Language API. This allows developers to incorporate Google's deep learning models into your own applications, and the API includes a sentiment analyzer that allows programs to determine the degrees to which sentences expressed a negative or positive sentiment. And they measure it based on a scale of -1 to +1. Now, Google declines to verify how the API is trained, so it's not quite open source for you to be able to sort of scrutinize it. But the process generally works like this. A machine learning algorithm takes a corpus of text labeled with positive and negative values, like movie or restaurant reviews or something like that. A positive score means that the algorithm sets a favorable sentiment, and a negative score is a means to determine whether the statement is not desirable. 0, like this statement here, I'm a dog, is a baseline. It's neutral. It's neither good nor bad, whether you're a dog. If you are a dog, then, I think you're good. But, the machine learning algorithm says this is neutral. And once the algorithm learns which words are associated with positive or negative scores, it can then bootstrap that data to learn about associations of other words by identifying which words are associated with other positive or negative words. So for example, if the word good in a review is assigned a positive weight, and then you often see the word translucent also used along with the word good, then translucent will be assigned a positive sentiment. Now, the problem is that artificial intelligence systems like Google's natural language API will inevitably absorb the biases that plague the internet at large. And here's a quote by Ernest Davis, who is a professor of computer science at NYU. He said, "It's easy to get around the bias for each individual problem, but getting around it systematically is very difficult." Google's head of AI said at his company's conference, "It's important that we be transparent about the training data that we're using and are looking for hidden biases in it. Otherwise, we're building bias systems." Now, Google did respond to this story, and they addressed these specific cases, but they continue to have problems with this algorithm. But they did say, we dedicate a lot of efforts to making sure the natural language API avoids bias, but we don't always get it right. This is an example of one of those times, and we are sorry. We take this seriously, and we are working on improving our models. We will correct this specific case, and more broadly, building more inclusive algorithms is crucial to bringing the benefits of AI to everyone. Next, we're going to talk about Compass. In 2008, the Broward County Sheriff's Office in Fort Lauderdale, Florida, decided that instead of building another jail, they would start using an algorithm to help identify which defendants were low risk enough to be released on bail pending trial. The algorithm is called Compass, and this stands for the Correctional Offender Management Profiling for Alternative Sanctions. Since then, nearly everyone arrested in Broward County was scored soon after being booked by this algorithm. And the director of community programs for the Broward County Sheriff's Office said that they chose the software because it was easy to use and produced simple yet effective charts and graphs for judicial review. And the system cost them about $22,000 a year to use. Now, the publication ProPublica obtained the risk scores assigned to more than 7,000 people arrested in Broward County, Florida. It's from these statistics are from 2013 and 2014, and they checked to see how many were charged with new crimes over the next 2 years. The same benchmark that they used for their analysis was also used by the creators of the algorithm. So I'll be going through a few examples of people who were committed similar crimes in Broward County and were affected by recidivism scores by Compass. Now, a lower score means they have a less likeliness of reoffending based on the algorithm's outcome, the model's outcome, and thus they get lower bail or less jail time. And then a higher score means that they have a higher chance of reoffending and thus have higher bail or more jail time. And you'll notice a pattern here. Now, between these two people, Brisha Borden was rated high risk for future crime after she and a friend took a kid's bike and scooter, and the items were valued at about $80. They were sitting outside the kid's house, and Brisha was 18 at the time. And while she did have a record, it was only misdemeanors on her record, and they were from when she was a minor, so we don't have details about what she did. But Vernon Crater was also picked up for shoplifting about $80 worth of tools from Home Depot. He was the more seasoned criminal, though. He had already been convicted of armed robbery and attempted armed robbery, for which he served 5 years in prison, and in addition to another armed robbery charge that was separate from that. Now, while Borden did not end up reoffending, Crater is now serving the 8-year prison term for subsequently breaking into a warehouse and stealing thousands of dollars worth of electronics. Now, Dillon Fugit, there on the left, he was rated as low risk after being arrested with cocaine and marijuana. He was arrested 3 times on drug charges after that. Gregory Lugo crashed his Lincoln Navigator into a Toyota Camry while he was drunk. He was rated as low risk, even though, despite the fact that this was his 4th DUI. And James Ravelli stole from a CVS and was caught with heroin in his car. He had already spent 5 years in a state prison in Massachusetts before this crime, and he was rated as low risk. He later shoplifted $1,000 worth of tools from Home Depot. And now I'm going to show you 2 charts that show the average scores assigned to criminal defendants. Here you see the average scores assigned to Black defendants across the 7,000 people that ProPublica reviewed. You'll notice a fair amount of the people evaluated here were set at a high risk score. And here's the chart for white defendants. These charts show that the scores for white defendants were very much skewed towards lower risk categories, and scores for Black defendants were not. In forecasting who would reoffend, the algorithm made the mistakes with Black and white defendants at roughly the same rate, but in very different ways. The formula was particularly likely to falsely flag Black defendants as future criminals, wrongly labeling them this way at almost twice the rate as white defendants. White defendants were mislabeled as low risk more often than Black defendants, and Black defendants were 77% more likely to be pegged as higher risk of committing a future crime, and 45% more likely to be predicted to commit a future crime of any kind. The first thing was violent crime, 77% more likely to commit violent crime, and 45% more likely to commit any crime. Now, North Point, their response to this was that they dispute these results from ProPublica, but North Point software is proprietary, so there's no way to really hold them accountable for what they're doing. And their software continues to be the most widely used software across the country in prison system recidivism scores. So it's still being used in the same way, and it's still affecting people the same way. Due to algorithm decision-making, populations that have historically been disproportionately targeted by law enforcement, especially low-income and minority communities, are slapped with high recidivism scores. That word's hard to say, recidivism. As a result, the algorithm amplifies and perpetuates embedded biases and generates even more bias-tainted data, and it feeds a vicious cycle. There are many different risk assessment softwares out there, but like I said, Compass is the most widely used. And recently, there was a conference called Data for Black Lives, and they talked a lot about this problem in the criminal justice system there at the conference. The Data for Black Lives, it's a community, it's a group of activists, organizers, and mathematicians who, they're all committed to the mission of using data science to create concrete and measurable change in the lives of Black people. One quote that came out of the conference really jumped out at me. You'll see it here. She's the director of data policy research at the AI Now Institute. Her name's Rashida Richardson. She said, "In my experience in conversations around AI, people talk about it like it's just a list of pros and cons, but that's a moment of power and privilege, to be able to determine that it's okay that some folks are disproportionately harmed." Now, more than 100 civil rights and community-based organizations, including the ACLU and the NAACP, signed a statement urging against the use of risk assessment scores. At the same time, more and more jurisdictions and states are beginning to use them, including the state of California, because they're trying to, it's like a Hail Mary effort to lessen the amount of people in their overburdened jails and prisons. Moving on to the next example, Amazon's facial surveillance technology is the target of growing opposition nationwide. But reports indicate that Amazon sold recognition to law enforcement in at least 2 states in the US, proposed the technology to ICE, and the FBI is now testing it as well. But in a test that the ACLU conducted of the facial recognition tool, the software incorrectly matched 28 members of Congress, identifying them as other people who had been arrested of a crime. The ACLU used recognition. They built a facial database and search tool using 25,000 publicly available arrest photos. They searched the database against public photos of every current member of the US House and Senate. I also want to note that they use the default settings that are recommended by Amazon on their website. So the false matches were disproportionately people of color, including 6 members of the Congressional Black Caucus. Now, citing critical concerns over immigrant surveillance of vulnerable communities, racial profiling, and other civil and human rights violations, Amazon shareholders have actually stood up and filed a resolution asking the company to prohibit sales of recognition to government agencies. The shareholder recognition resolution echoes over the concerns of over 70 civil rights and civil liberties groups, hundreds of Amazon's own employees, and 150,000 people who signed a petition, all seeking the end of sales of recognition to government agencies. Now, the crop of shareholders who introduced this proposal, they represent over $1.3 billion in assets under management. So not only does the sale of this tool to government agencies, put people in danger, but it also really is bad for business for Amazon. So they have to listen. They want to save that money. Next, I want to talk about the Gender Shades project. This has gotten a lot of attention, and it's a really impactful project that came out of MIT by a person named Joy Bolenwini. And they wanted to see how well different gender classification systems worked across different people's faces, and if the results change based on somebody's gender or skin type. And she analyzed 3 companies: Microsoft, Face++, and IBM. And IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. Joyce said, if we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. So what can we do to work towards fixing these problems in algorithms, affecting people's lives? First, I suggest you listen to this podcast. The Ezra Klein Show is a really great podcast. He interviewed Anil Dash about the biases of tech. And these are just biases in general, not necessarily about machine learning, but they do talk about machine learning on the podcast. But if you're not familiar with Anil Dash, he is the CEO of Glitch. He's on the board of Stack Overflow, and he's part of the nonprofit Data and Society and the Research Institute. And one thing Anil said on Ezra's podcast really jumped out at me. He said, coders are the most empowered laborers that have ever existed. Yes, you have to meet deadlines and requirements, but you also have the power to ask questions really early in the development process and the data collecting process. And you can prioritize the mitigation of bias from the onset of the development process. And there are tools out there to help you with ensuring that your algorithms aren't biased. And as a data scientist or developer, you're in a position of power, whether you realize it or not. You can prioritize the use of these tools to ensure that the applications you build are fair and just. I also think that better education is really key to encouraging more people to consider those affected by their algorithms once they're out there in the world building things for real people. We need to recognize the choices that we make when we build new technologies, that they can have dire consequences for people. As such, universities are beginning to require computer science majors to take ethics and morality courses. Cornell, Harvard, MIT, Stanford, and the University of Texas are among those colleges that are requiring this in their students graduating from their computer science programs. And some of the questions that they're posing to their students include, is the technology fair? How do you make sure that the data isn't biased? Should machines be judging humans? The new ethics courses cover topics like artificial intelligence and autonomous machines, privacy and civil rights, and platforms like Facebook. I want to go back to the data for Black Lives Conference because more amazing information came out of that. What about those of us that are already in the field? We don't have access to these ethics and computer science courses. There are many questions we could be asking ourselves as we're building these algorithms. We can say, who counts? Who is doing the counting? Who created the counting mechanism? Who is asking for the data and why? Who determines who is counted? Who determines data integrity? And who breaks the cycle of bad data and why? A lot of people talk about a broken pipeline when they talk about tech in terms of our lack of diversity in tech. And I would say that the pipeline isn't actually broken. There is diversity in this field already, and it's growing every day. Well, we need to work extra hard to ensure we are giving diverse voices a seat at the table and giving them agency to make a difference. And it's undoubtedly true. Right now, the majority of these popular machine learning algorithms are pretty much built by cis white men. Rediat Abebe founded Black in AI. Black in AI started as a community where Black people could come together who might not have had the opportunity to meet each other otherwise. The goal is to diversify the field so that people who ask the questions and set the objectives in building AI becomes more diverse. And thus, the algorithms that come out of that are trained on more diverse data and have less bias. Now, here's a great example of what happens when you diversify your team. Pinterest has launched a new feature on their website, which allows for a search feature that filters by skin tone. And I thought this was actually interesting because you hear mostly about applications of AI using skin tone that create racial bias. But in this situation, you do want people to be able to choose based on skin tone to get them the products and the services that they really need for themselves. Their idea behind this is that those people looking for beauty tips really need to find relevant hair and makeup advice regardless of their race. Pinterest said that the skin tone feature is a direct result of the diversity and inclusion efforts that the team has pursued. The diversity and inclusion team works closely with the technical and engineering teams within the company. And Pinterest is one of the first tech companies to not only publicly release annual company diversity reports, but they also set yearly public hiring goals. What's more, Pinterest also reported that women now make up to 47% of the company, and 30% of people in technical roles are women as well. It makes this one of the most gender diverse companies in the industry, especially when compared to companies like Apple, Google, and Facebook. In fact, Pinterest's head of diversity and inclusion works hand in hand with the product and engineering teams to produce more inclusive features on the website. And Pinterest made gains in inclusivity by actually having more diverse ranges of thought at the table when building their algorithms at the onset. Now, I have to put my IBM hat on here, obviously, because I work for IBM and I love IBM. And we did respond to Joy Buolamwini's research in a few different ways. We went on to build the AI Fairness 360 Toolkit. This toolkit is an open source library of metrics to help you examine, report, and mitigate discrimination and bias in machine learning models throughout the AI application lifecycle. It includes fairness metrics for data sets, machine learning models, explanations of these metrics, and algorithms to mitigate bias in data sets and models. It's a little different than what's currently available in open source efforts due to its focus on bias mitigation as opposed to simply on metrics. It's a Python package that contains a set of algorithms developed by the broader algorithmic fairness researcher community to control unwanted bias. The site contains, it's got 3 tutorials available. The tutorials are on credit scoring, predicting medical expenditures, and classifying facial images by gender. And we've provided an interactive experience that includes an intro to the concepts and capabilities of the toolkit. There's guidance material that can be used to determine which metrics and algorithms are most appropriate for your given use case. And everything you need is really built in there. It includes over 70 fairness metrics, explanations for each, and a bunch of bias mitigation algorithms. Now, when talking about fairness metrics, the word fairness is not an easy thing to define. It's multifaceted, it's dependent on context, it's really defined by social construct, which varies by situation. And our toolkit is really useful in achieving justice in many situations, but it can't fully capture fairness in every situation. The process really requires broad discussion with multiple stakeholders in your development process, with input on overall decision-making workflows. So the toolkit really only works when the problem you want to solve is very well defined. So with 70 plus metrics to choose from, you'll really need some help to decide what will work in any given situation. These fairness metrics are basically different definitions of fairness and allow you to better classify what you need to solve the unique problem at hand. So we'll go through the three different types of metrics here. Let's skip ahead a little bit. Hold on. Okay, there we go. So individual versus group, or group fairness, or both. Group fairness, in its broadest sense, separates population into groups defined by protected attributes and seeks for some statistical measure to be equal across the groups. And individual fairness looks for similar individuals to be treated similarly. It's possible that you might need to account for both of these things simultaneously, and we have metrics to account for that as well. Next, group fairness, the data versus the model. So the metrics that fall into this class contend with the difference of measuring fairness at different points of the machine learning process. So if you need to control your metrics while the data is being trained, you could use different metrics than you would if you need to apply metrics to the model after it's finished learning. The last one is, or second to last actually, if there's four. Group fairness, we're all equal versus what you see is what you get. With we're all equal, you should assume that all groups have similar abilities with respect to the task. While the WYSIWYG, you assume that your observations reflect ability. For example, in college admissions, using the SAT score as a way to predict success in college, the WYSIWYG worldview says that the score correlates well with future success, and that there's really a way to use the score to correctly compare different people and their abilities. In contrast with the we're all equal worldview, it says that the SAT score may contain structural biases. So a difference in scores across different groups should not be mistaken for a difference in ability. Now, the last metric type is group fairness, ratios versus differences. Some of our metrics deal with the difference between the data sets you're using for your model, and some metrics set ratios that allow you to set fairness metrics. So what you decide to use really depends on the problem that you're trying to solve. So as an example from the ones that are featured on our site, the statistical parity difference is the difference of available outcomes received by an unprivileged group compared to a privileged group. Now that we've covered metrics, we'll move on to algorithms. The bias mitigation algorithms available here attempt to improve the fairness metrics by actually modifying your training data. They also modify the learning algorithm and the predictions, or the outcomes. Part of your decision on which algorithm to use is really contingent on when you're able to intervene in the machine learning pipeline. So here here are different categories that are available to you. If you can modify the training data, then pre-processing can be used. And if you're able to change the learning algorithm, then in-processing can be used. If you really can only treat the learned model as a black box without any ability to modify the training data or the learning data, then only post-processing can be used. We really recommend that you jump in as early as possible in the machine learning process because it gives the most flexibility and opportunity to correct bias as much as possible. And if possible, algorithms from all permissible categories should be tested because the ultimate performance really depends on the dataset characteristics. There is really no one best algorithm to fix any given problem. As an example from the list here, optimized pre-processing is when 90% of your data set is male and 10% are female. You would reassign 90% weight to the female side and 10% to the male side to bring equal parity between the two. Now let's check out one of the demos that is available on our application. Let me see if I can launch the browser here without any hiccups. Okay, so you can see, oh, it's getting cut off a little bit. Let me go out of full screen mode here. Okay, and I'm just gonna zoom in a little bit. Okay, so you can see that we have 3 demos available here on the website. You can go through all 3 and learn a lot about the different algorithms and metrics that are available. I'm gonna choose the first one because we already talked about it, the ProPublica recidivism scores from Compass. We got access to this data and we used our AI Fairness 360 toolkit to evaluate it. So you'll see that we ran a basic machine learning algorithm built to predict the criminal defendant's likelihood of reoffending. As we said before, we weighted the scores based on sex and age. Sex and race. For sex, the privileged data is actually female, meaning they usually get less jail time than men. And the male is unprivileged, meaning they get more. And then in the race categories, the privileged class is Caucasian, meaning they get less jail time, and the unprivileged class is not Caucasian, meaning they generally get more jail time. So let's just click next and let the algorithm run. Okay, so you'll see that through the different algorithms here, there is quite a bit of bias in the between the privileged and unprivileged group. It has a negative 0.36 amount of bias on the sex, and by race, negative 0.18. Now, if we take a look at the different mitigation algorithms available, we'll choose the reweighing one. This weighs the examples in each group combination differently to ensure fairness before classification. And then we'll run this algorithm. And now you see the difference between the two. So we had a negative 0.36 statistical parity difference, and now we're almost at 0, negative 0.03 for sex. And then for race, we actually went into the positive. So it was a negative 0.18, and now there's a positive 0.02 parity difference between the two. So as I said, you can go through and play with this a little bit more. But it's a great tool for learning a lot more about the toolkit and figuring out how it can work for you. Now, all of this is available for you on GitHub. As I said, this is open source. It's free for you to use. And this is also how you would contribute to the project. So for example, when we pushed the toolkit live, we started with 9 bias mitigation algorithms. And within the first week, we had someone in the community contribute the 10th bias mitigation algorithm to the toolkit. So we would really love your contributions and your feedback here. There's also an active Slack community. So if you want to use the toolkit and you want some help with getting started, you can join us on Slack and get help from us directly as well. Now, transparency around the data that machine learning models are trained on could really help identify cognitive bias. With open source deep learning models, you have the ability to see and contribute to the models that are processing the data. And this is where I want to talk about our model asset exchange. Now, Max is not just a one-stop marketplace for multiple free and community-sourced frameworks, but everything you need to understand the metadata, the origin, and the quality of the community models. The hope with this project, say that again? Oh, sure. I'm just going to go back to full screen again. Give me just 1 second here. Okay, here we go. So the hope with the Max project is that we create transparency around the building and training of these models and ignite a community of people around the open source contributions towards solving really big problems that need solving in machine learning algorithm building. At the moment, we have 25 different models available. I think we just released one more, so it might be 26 now. They range from the audio sample generator, which generates audio clips of speech commands, to the human pose estimator, which detects humans in an image and then estimates the pose. And then there's also the breast cancer mitosis generator, which detects a mitosis in an image of a breast cancer tumor cell. Now, an important thing to mention about this project is that you can access the full data set for these models for what they're trained on. And we're also really intentional in our desire for full transparency around the models. Now, as I said, the models are all available for you to use right now. They're free and open source. You can embed them into your applications and just get going without writing any code. And you don't have to know anything about machine learning to pick them up. And you can gain some pretty nifty pre-trained models and do some fun things. For example, my friend and coworker, Nick Caston, he's on my team, he took the image segmenter model from Mack and made the magic cropping tool. So with zero coding, you can interact with and get predictions from the deep learning models using your own data. Now, the way that this works is he just uploads 2 different images into his application, and then the Max model segments out the pieces that you want it to identify, and then you can superimpose them on each other and make really cool memes for your social media antics, and it's really fun. So I encourage you to go play with it if you'd like to learn a little bit more about how to use the Max model. So by building open source models and training data, we increase transparency, we provide more opportunity for hidden biases to be uncovered, but it doesn't solve the problem of cognitive bias in machine learning as a whole because it's just the models themselves. It just creates transparency, but it does open the door towards more collaboration and innovation in this space. And so that's why I think open source is truly an answer to the problem of bias. Now, just announced recently, IBM researchers have developed the Diversity in Faces data set, and this seeks to advance the study of fairness and accuracy in facial recognition technology. It's the first of its kind available to the global research community. It provides a data set of annotations of 1 million faces. And the images come from a publicly available Creative Commons data set. It provides a more balanced distribution and broader coverage of facial images compared to previous data sets. The insights we've discovered from the analysis of the 10 initial coding schemes on this data set has really furthered our own understanding of what is important for characterizing human faces and enabled our researchers to really continue important research into ways to improve facial recognition technology. You can access this data set. It's available today to the global research community, but it's only available upon request. Admittedly, you need to provide a pretty fair amount of information to access it, and you have to promise that you're going to use it solely for research. And I found out that the reason for this is while they were developing this data set and putting this together, the laws in the UK, I always blank on the name of the laws, the privacy laws in the UK, you know what I'm talking about. They went into effect and we aren't able to identify if anyone in the data set is a citizen of the UK or could be in the future. And so it can't be used for commercial purposes without violating that law. But IBM is very proud to make this available, and our goal is to help further our collective research and contribute to creating AI systems that are more fair. Now, remember the Gender Shades project from earlier in this talk. Recently, Bolamwini released an update to the Gender Shades project by retesting the previous systems that she'd examined and expanding her review to include Amazon's recognition and a new system that I haven't heard of before called Kairos. And there is some good news. She found that IBM, Face++, and Microsoft had all seen significant improvements in their gender classification accuracy for darker skinned women, with Microsoft actually reducing their error rate below 2%. And while IBM did little more than halve our rate in accuracy overall, obviously we still have some work to do in terms of making this more fair. But this is why we're really committing all these resources to this issue. Amazon and Kairos's platforms both had a 31% and 23% accuracy gap. And Bolawini said that the study shows the need for these technologies to be externally audited in order to hold them technically accountable. You can actually volunteer your time to join this fight for equality in machine learning justice. The Algorithmic Justice League has a sign-up form on their website where you can volunteer to test software and build inclusive training sets. They also have ways to report bias and submit your data sets to be checked. Joy Bolawini started this collective as a way to combat bias in machine learning. I think she's a wonderful person, and I greatly admire her. So I encourage you to watch her and what she's doing and join this project. So in conclusion, we really need to contend with the fact that data is generated based on human behavior, and algorithms are built by humans. So no matter what, as technology practitioners, it's our responsibility to build systems that are fair. No one who built these projects that I talked about, at least I don't like to believe that they did these things on purpose to hurt people, but the reality is that they did, and they continue to. And it's our responsibility to stop it. Whether this means making better decisions when building these tools, or pushing for legislation to protect privacy and freedom, or working to build a more inclusive work environment for people to solve these problems, we all have a role in the fight for justice here. So I have a bunch of sources available for the things that I reference in this talk, and I provide them really easily for you in my slides. So you can go to this bit.ly link and access my slides from this talk, and also in the notes below the slides, you'll see a bunch of resources available to you to learn a little bit more. So I want to thank everyone for joining me today. Oh, I was just going to say, does anybody have any questions? Great. Yeah, thanks to everyone for joining me today. I really appreciate your time, and feel free to reach out to me on Twitter if you have any questions or want to chat with me or want to connect. So thank you so much.
Hello, everyone. Hope you're having a great day. So, I'm Sashwati Swaminathan, developer advocate from IBM Kodai team, which is Center for Open Source Data and AI Technologies. I'm super excited to be here, and thank you so much for making me a part of this session. So, let's start. Uh, we are going to see, we are going to have an introduction to deep learning and also what is IBM's Model Asset Exchange is all about. Okay. So the agenda for the day is we're just going to see what is data science and data science pipeline. We're also going to see a very high level overview of the deep learning algorithms. And I'm going to introduce you all to Model Asset Exchange. We're going to see a quick demo and we're going to wrap it up with a message as usual. So quickly into this. What is data science? You all know, like it's like it has become a ritual. Like whenever you start presenting something, you start with a definition. But I don't want to use any book definition. Rather, I thought I can just split the definition into four parts. So, what is the goal? The goal of data science is to find solution to your business problem, and how we are going to do it. So, we are going to take a business problem and convert it into a data science question. And then we are going to use our mathematics, programming, and scientific method to find answers for these business problem and our questions that we created out of it. And finally, we are going to communicate the result and also see the business impact it has created. Like, what is the business impact of the solution that we created? So this is all a quick definition of like what does data science. So before getting into the next slide, I would like to tell, say for example, you have your business problem defined, you have your data science question, and you are an expert in mathematics, programming, and scientific method, but you cannot take the data that you have and directly give it to your machine learning model or a deep learning model and expect it to perform, perfectly give a state of art result. You can't. So it's like garbage in and garbage out. So what do you need to do? Like, how can you make your data speak right? So that's when we get this data science pipeline. So what is this pipeline is about? So we start with data extraction, as you can see here, and then to data cleaning, then data exploration, and then comes the model development. And we are going to interpret the result. And if we are not satisfied, we are going to go back to the first step, which is data extraction, and then go on from there. So this is called data science pipeline, and it's really important to send your data through this process in order for it to give proper answers to the questions that you're creating. Now, the focus for the day is going to be model development here, especially deep learning. And I'm sure like you're super excited because this is like the most celebrated part. So whenever you say, someone as a data scientist, we we think like, okay, they are automatically predicting things, and it's such a cool thing to do. You feel like a wizard. Like, so we are going to see a very high level overview of deep learning and get into model asset exchange quickly now. So what is this? Like, you're seeing a picture here, right? At once you see this picture, you will know it is a cat. So how do you know? How do you know it is a cat? We are subconsciously analyzing things that are around, we are labeling them, and then when we see it in the next time, we are able to predict it. So our eyes and our brain are collaborating with each other in analyzing things around, right? So your vision starts with the eyes, and the interpretation is done in the brain. So this is how a human neural network, a human brain works. This is how we analyze things around, and this is the inspiration for deep learning. Deep learning is inspired the neural network. I mean, deep learning neural network is inspired from human neural network. we are going to give this human intelligence to machine, and that's called artificial intelligence. I hope you are getting it now. So, what is deep learning? It's a machine learning with large, deep neural network. I have on your right side, you can see a very simple, very basic neural network here. There is one input layer, there is one hidden layer, and output layer. So every single circle here is called a neuron. It's you can think of neural network like circles and lines interact with each other. So that's how, in an easy term, you can understand. So this machine learning with large deep neural network is called deep learning. Now, deep learning is not something that is there. For about it's been there for a long time, but all of a sudden it's becoming more popular. Why do you think deep learning is becoming more popular now? It is because we have access to huge amount of data, and also we have powerful computers to compute these data effectively. And one last important point, as you can see in the graph on the left side, it's between data and the accuracy. So as the amount of data increases, the accuracy of the model goes high in deep learning, whereas in traditional machine learning is not able to cope up with the kind of performance that deep learning is giving you, and it automatically learn all the important features. Whereas in machine learning attempts, you need to tell like what are the features that are important. So deep learning outperforms machine learning when it comes to the amount of data that you're using for processing. So that's why it's like more popular now, right? So what's a flow? So we take the input, we pass it through the neural network, and we compute the loss. So what is a loss? Say for example, I'm predicting a salary of an employee, and the salary of an employee is like some $100, for example. If my model predict it as 90, the $10 difference is called a loss. Now I'll try to adjust my parameters using optimization algorithm, and we tune the parameters and try to push my data again to the network. I will do this process continuously till my loss gets to the minimum value. So this is the entire flow that is happening. The goal is to minimize the loss. So what happens inside a single neuron? Okay, say for example, you have two input values, x1 and x2, and your target is y. Inside that single neuron, I mean inside that one single circle, what is happening inside that one single circle? Now, will be this will create a linear relationship between your input, which is x1, x2, and output, which is y. Your linear equation will have two components in that. One is constant, here it is denoted as b, and other is a product of your input and the coefficient. Here it is x1 is the input and its coefficient is w1. We will get this linear relationship, and then we will pass it to a non-linear function, which is called activation function, and you will get the output. So what does this activation function does? I'll give you a very simple example here. One of the commonly used activation function is sigmoid. Say for example, I have output value of 2 from my linear equation here. This y is equal to w1 x1 plus w2 x2 plus b. This is my linear equation, and the output that I got from this is 2. And the x-axis denotes the output of linear regression, and the y-axis is the output of my activation function. As you can see here, no matter what your input, your output value will always be between 0 to 1. 0 to 1. So we take 2 as the output from the linear regression and hit it in the graph, go to the y-axis, You can see it's around 9 or 0.9 or 0.95. So that will be output. So this makes the linear to non-linear conversion. And this is what happening inside the single circle, single neuron. And if you connect all the neurons together, it becomes perceptron. If this is like a single layer perceptron, sorry for the, I think I have mentioned multi-layer, but it's a single layer perceptron. But multi-layer, you'll have more than one hidden layer here. If you have more than one hidden, it's called multi-layer perceptron. You are just adding all the circles, and all the circles are interacting with each other. I'm not going to go in depth to all the math. I'm just giving quick, very, very high level overview of the algorithms here. And then comes the convolutional neural network. As you can see here, the input layer and the hidden layer on the left side is your multi-layer perceptron. On the right side is your convolution neural network. They're all in 3 dimensions. They all have depth, height, and width. So they are all organized in 3 dimensions. And it uses convolution and pooling methods to extract all the important features. And as you can see on the left side, all the neurons are connected with each other, whereas on the right side, which is convolution neural network, they're not connected with each other. I think in the future we'll have like a detailed session of how every single algorithm works. For now, this is what it's a very high level, very, very high level overview of how what it is. Cool. So we all seen like but say for now this is a real game, all these are algorithms, cool, everything is fine, it looks like amazing, but what's in real time, what it does, like how we can use it. So for you can see the image here. Let's take a very simple use case. This is an image here, and what you need to do is first you need to understand what is happening in the scene, and then you are going to predict what is the sentiment of the scene, whether it's positive or it's negative sentiment, like what is happening in the scene. What you'll do, like you need 2 algorithms here. One is caption generator, like image captioning your image, and then analyzing the sentiment. You need sentiment analysis model. Oh, so the algorithms which we have seen, they are very basic. You need like such well-defined architecture for doing for creating such real-time applications. What are the challenges you will face when you're creating such use case? First, it's very important to know what are the available model for the problem. So here, for example, I have my image caption generator, right? I need to know what are the algorithms that are available in the market which can actually do this caption generation. Okay, now I know. Say, for example, I have like 100 new algorithms in market for this application, and trust me, it is there. Like if you go and search for object detection, you will see like more than 100 models, like a lot of research papers, a lot of algorithms for that one particular application. And what you need to do is now we need to pick out the best working code. Out of 100, what is the state of the art, like which works the best? And then you need to take the code, and then you have to solve all the installation, all the requirements, installation issue, clean up the code, and finally get it running. This is not impossible, but it takes a lot of time. It's a very time consuming process. It takes a lot of time to do this. And that's why we thought we need something called model asset exchange. So what is this model asset exchange? This is one place for all open source state of the art deep learning models. And the models are categorized into wide varieties of domains. By domains, I mean we have models in images, we have sound like audio, video, natural language processing, cryptography, time series. So we have models in varieties of domains. And Yeah, this is one very important feature. So when you pick up a model from Model Asset Exchange, you can be very sure like it's a well tested code and IP. You don't have to worry about all these things. And we have both trainable and trained version of the model. So why did we actually do this? Like, what is the necessity of creating such models? Because we want a deep learning models easy to consume. So, for example, you have your phone, right? We all have no idea like what IC is being used, like how the connections are made inside, but we still use it effortlessly. Uh, so that's the goal. Like you want people to use AI just like how they use their telephones. I hope I'm going pretty slow. Okay. Now, what is the behind the screen? Like, what do we do when we create every single model in Model Asset Exchange? We go and find out all the state of the art models that are available in the market, and then we figure out what is the best out of the best, and then we start validating their license term because we want to make sure that IP is right. And once we get clarity, once this got cleared, this step license step got cleared, we'll take the model and we perform health checkup or code cleanup because we want to make sure that it's bug free, there's no error in the code, and if it requires any improvement in the architecture or any improvement that we can make it to the model, we will do all the changes, and then we start wrapping the model in an exclusive framework that we have for Model Asset Exchange, and then wrap it in Docker container using the framework, and we provide REST API access to it, and then we kind of start testing the model. We have like 4 to 5 peer reviews, and we do continuous integration. And once we are done with all these things, we will release the model, and we want to make sure we also do version control because we want to make sure whatever models you are using is up to date and it doesn't have any bugs. So we also do version control. So this is what happening behind the scene, like when we create every single model in Model Asset Exchange. So what is the next step? So this is what people generally ask me when I talk about it. As a user, what can I do? Like when I get into Model Asset Exchange, what can I do? So I'm categorizing user into 3 different categories. First is beginner, intermediate, and expert. Say for example, you are a beginner, like you are so passionate about deep learning and you have just started studying it. I want to know how the model looks like, what it feels to use the model. What can you do is you can go and try different pre-trained model, use the REST API, access it, learn about the paper. We have linked all the research papers there. Go and learn about it, and then get a feel of how it works. Coming to the second stage, now you are the intermediate user. You have started. You are get settling down in the deep learning, that ocean, and you know how the model works. So you can understand the math behind algorithms, and you want to create your own application, right? So that's the next good step that you want to take. So you have your own data set, use the trainable models, and then create your own application. So we have provided detailed steps on how to start training the model, what kind of data set you want to train the model. So use the deep learn trainable models and go and access it. Third, now you are an expert. You have done in the intermediate stage, you have created an application which will classify between cat and a dog, right? Now you want to transfer the learning and use the same architecture with little tuning there, and I want to use it for classifying cancer images. So we will be soon introducing transfer learning models there. Then use the model, and then use the same model that you have used for image classification for this cancer images classification with little tuning. So these are the steps that a user can do who are in different categories. And if they want to try out anything, they can feel free to go and try it out. Cool. Okay. Now, all my talking slides are almost over. So I'm going to show you all a quick demo. I hope you can see the screen now. So, are you able to see the screen? No. So what I'm going to do now is I'm going to take you all to the Model Asset Exchange page here. So this is our Model Asset Exchange page. You have deployable and trainable models here. So I'm going to quickly pick up object detector model. If you get in, you will have an overview of what the model is about, model metadata, references, license term, and how you can use it. If you want to see what is there, you just click on get this model. It will take you to the GitHub page which has so I'm going to show you. Okay. I hope you can see now. So I'm going to start from first. So this is our Model Asset Exchange page. And there we have like deployable and trainable models. If you want to try the tutorial and know like what this is about and what are the features we have, feel free to go click on the tutorial and go to the learning path and actually get to know what is about in depth. Today I'm going to try object detector model. In the landing page, you have like what is this model about, in which data set it's been trained on, which is the architecture that it is using, and what's the metadata, references, license term, and how to use the model. I'll just quickly show you what happens if you click this, get this model. Okay, it will take you to the GitHub page, which has information about all the which has code and more detailed information of the model. So you can see here we have steps like how to deploy from Docker Hub, how to deploy on Kubernetes, and how to build your model locally and use it. I'm going to try this one now. Okay, so I think I'm going to pass the share and then quickly get to the terminal. Okay. I'm just making text bigger so that you can see. Okay. What I'm going to do is I'm going to run the object detector model. It will pull image from Docker Hub. And then it will run your model in localhost port 5000. Okay. So this is the REST API I was talking about. Like the model is running there, and if you want to try, choose the file. And what is the threshold? So I will explain the threshold better when we see the app version of the model. So you can see the prediction. I will also run app version of the model here. We have, so I'm just uploading the image and the model is predicting now. So this is a Swagger API here, and this is the app version of the same model. Play around with the threshold. So if you decrease the threshold, you can see there are a lot of false positives here. You can see like bench, there is something called predicted as car, and there are a lot of false positives if you keep decreasing the threshold. If you increase the threshold, you will get a, true positive, which means like your system will tell you accurate results. If you increase the threshold, the classification will be proper. And there's one more here. So if you want to see only teddy bear here, you can just click on the other label so that it will disappear. And if you want to see only person, so click on that, it will show you only the person. So this is one of our models. It's called object detector model. We have, as you can see here, we have API version of that. We have web app version of that. We have also created Node-RED flow of the same model, which you can go and use. So I guess so. How the app version works? If you see here, what it does is from the web UI, the request is being sent to the model API that is running, and the model API will do the in turn, call the TensorFlow model, and it will run the prediction, and then it will display the detected objects here. So that is what happening when we create a web app using the object detector. And if you want to try it out, if there's a tutorial app that is there, which I will share the links at the end of the session, and you can actually go here, and then we have like an exercise where you can go and play around with the web app creation. So feel free to go and try it out to get a feel of how the web app actually works. And I can show you one other model, which is age estimator model. I'm just closing this, and I'm gonna try that age estimator model. I'm gonna restart my Docker so that I don't have any problem with the production. Cool. Let me quickly try the API here. Try it. Click on the try it out option. Don't forget that only then you will get the option to load your image. And I want to give my own picture and see how it predicts and what it predicts. You can see here that my age has been estimated as 24. I'm so happy about it. And also it gives you the bounding box. If you are not sure what the bounding box actually means, I will show in web app version of the same. Okay. So here it gives you where the face is exactly. And also if I try this, let me try it out with this one. And also it will tell you what is the age. So this is like app version and also the API version of the same model. And feel free to go and try it out and let us know what you feel about it. Okay, so I'm done with my all the technical things that I wanted to talk about. And I'm not sure whether I will get this good chance anytime in future. Like when I don't know when I will be getting this chance. So I want to use this chance, since it's Women's Day special, to thank like wonderful women who actually helped me in my career. to grow, to be a person that I am now. So it is a thanking time for them. There are a lot of people involved, but I specifically want to thank people in IBM, like who actually helped me to be like who I am today. So first, she's not from IBM, but still, to my mom, as usual, like she was the one who taught me, do what you love. Don't do something because everyone does that. Do it for the sake of your own satisfaction and go behind your dreams. So thank you, mom. And Madison, she was my colleague before, so she was the one who told like, I trust you. You are more than what you imagine you are. So that's the first ever motivation that I got. And thank you so much. And Gabriella, I can't thank her enough. Like every single time, she gives me a lot of tips. I can talk anything random to her, and without being, afraid of, without getting the fear of being judged, I would say. So thank you so much, Gabriella and Vanita and Lisa. They also helped me in my advocacy part because I was a person who was, behind the computer, and I have never had this chance of doing talk or something. So they actually motivated me, to get into this part also. So I'd like to thank all the wonderful women and Amara, everyone for giving me this chance. They just, you all rock, like not just them, like whoever around the world seeing this or not seeing this or going to see this later. Thank you so much. And there are two quick messages that I wanted to share. So this is the first time I'm sharing some message which I always wanted to do it. The first thing is be a seeker and not a believer. Because when you believe something, you always need a group. Like you want to be with someone. So you always need a group if you are a believer. But when you're a seeker, you will never be afraid to walk alone. You will take steps that will challenge you. So I would, this is not some advice or something that I'm giving or philosophy, but it's from my experience. So be a seeker all the time and not a believer, and don't be afraid to walk alone. Since it's a Women's Day special, I thought of sharing, this message with you all. Hope you like it. And the final message which I wanted to give you is work-life balance. You know, we all are talking about work-life balance, or like how it is going to work out. Let me tell you something. So on an average, we spend like 30 to 40% of our lifetime in work. So there is nothing. So do you still think work and life are two separate entities, two separate, attributes? It's not like that. So if you feel work and life are separate, then please don't take the work that you're doing. Do what you love. So your work and your life, it's not like work and life. It's professional life and personal life, balancing both. So it's life versus life, right? And also, I would say involve your family in your work, share what you're doing with them, and take their inputs. I'm sure you're going to get a lot of really cool inputs from them, and they will also feel like they are part of something. So if you just show them the balance sheet, like money aspect, they'll be like, okay, you're showing me the money and where I can use it, right? So take them and make them be a part of your work, and then talk to them about it. And if you're passionately creating something, you will have a lot of interesting stuff to talk. It's like you should live all the 7 days, because I have seen you know many people saying that I work for 5 days and I live 2 days. I would say live all the 7 days and do what you love. So that's the message that I wanted to give you all. And there's a quick summary. So we saw what is data science. We saw data science pipeline, a simple neural network, and we saw what is Max, model asset exchange. Don't forget about it. It's one place for all open source state of the art deep learning models. Feel free to go and try it out. It's a well tested code and IP. And you can and then I showed you how you can build and deploy model as a web service in less than 30 seconds. And also feel free to go and try our trainable models. You can just start training in Watson Studio in less than few minutes, I would say. This is an amazing resource that we have as an open source, and I urge everyone to use it and get a benefit out of it. And thank you so much for giving me this opportunity. It's a great pleasure to be here. So, yeah.
All right. Hey, wait, I don't see it yet. Okay. This will be interesting. Okay, this is messing with me. All right, let me go away Zoom. Okay, I'm just not gonna look at any of it. Hi, my name is Augustina Ragwitz. And I'm currently looking at 2 screens of myself. One of them is on our Zoom thing, and then I'm like sort of monitoring the Twitch feed here. So let me just put that out of the way because it's just really messing with me. Let me get myself situated here. Okay, so things are everywhere. Okay, sorry, I don't like Zoom and things and screens. Okay, so so I work for our IBM Cognitive Open Tech group. I'm an open source AI advocate. Although I like to say that I'm an avocado. Like I've been trying to do this thing. So I'm like, there we go. Finally, I'm sorry. I just was like, this thing was messing with me. I could see myself and it was just bothering me. Okay, move that out of the way. Okay. Where was I? Oh yeah, so I work on our cognitive open tech team, and so I'm an open source AI advocate, and I've been doing this thing like so. I like to say avocado because I think that's funny, and so like I'm wearing my little avocado pin because I'm avocadoing right now, or like I don't know how you conjugate that avocado. I'm not sure. Anyways, but I'm trying to get this started as a meme because like I just think it's really cool. I think it's really funny. It's like I'm a developer avocado. Yeah. So what does an advocate do? What does an avocado do? Finally, I think this year I realized that I'm working in marketing, basically like pretty much like developer to developer marketing. And so more like brand reputation marketing. I actually like selling products. And my goal is to generate relevant content that gets people's attention, right? That's the party line. That's what we're supposed to do. And that's kind of an interesting thing because right now everything's about attention. That's like the big commodity online. How do you get people's attention? As a Gen Xer, like I've grown up with Rotten.com. Well, not grown up, but like in my college years, there's like Rotten.com and LemonParty.org and all this crazy stuff. So I mean, like I've seen a lot of weird stuff. A lot of people in my generation and like younger, it's really hard to get our attention. And as a person with ADHD, like I know from firsthand experience, you don't get people's attention by talking at them a whole lot. Like, that's a kind of different attention, more like a train wreck kind of attention, not what I would call like, positive attention. So I think the way that you get people's attention is by listening. And so what I think the value of advocacy is, it isn't actually content. It's not, let's generate and push out all this relevant content, that we produce and what we put out. I think it's the stories that we bring back that you share with us, that all y'all, that we interact with in our open source communities, and all of you folks that are, that don't work for IBM and are like watching the stream because you're curious about what we're doing and you find it relevant to your lives. It's bringing back your stories through our relationships and then building stories together that add that thickness to the impersonal quantitative market analysis. That is our value. That's what it means to avocado weight, or I don't know. If you guys can help me with that conjugation, I'll take suggestions. So I'm gonna go ahead and get started with my talk. I never remember the name. What did I call it? Oh yeah, cutting on the bias and against the grain. I thought it was pretty clever. Anyways, this is something I'm working on. So this is a work in progress. And what I've got here, I actually want to start out talking about Madeline DNA, and I've got to check the video real quick to make sure that I'm holding this up. Oh, it's delayed. Shoot. Okay. Okay, higher. All right. Okay, is that better? I should open up the Zoom. It's just too many windows. Okay. Okay, sorry, I was getting some help from the director over there. Okay, so he'll let me know if it's out of whack. So Madeline BNA was a fashion designer. I'm curious, actually, let me get the Twitch stream back up. How many of you all are fashion nerds, like that are kind of into that kind of stuff? Because I know I am. I don't know. Let's see. So Madeline BNA, she was a designer that really came into fruition in post World War I. Sorry, I'm trying to find the Twitch stream again. Okay, there we go. All right. Yes, here we go. Okay, got everything organized. Yeah, computers are hard. Okay, so World War I fashion designer. So she sought to redefine the feminine experience through the clothing that she designed, and she ultimately invented techniques that used fabric bias to express her views and her idea about the feminine experience and what femininity is. And so these clothes were very close fitting with increased movement. And we're talking about like the early 1900s, so post World War I. You know, this is a time of corsets and all kinds of fun stuff. And so women were very much encased in their clothing. And so what I thought was kind of neat about V&A is that she was really into geometry, and she was really inspired by Greek vases. I don't know how you say that. So here I'll show the picture. And so this is like an example of some of the geometric concepts that she was playing with, and the spiral in particular. And so why she needed to do this? Why she probably talked about what the bias of fabric is. So this isn't silk. This is some like, you know, kind of cheaper. Well, it's nice satin. It's not cheap satin, but she would have had silk at the time. And so the bias, if you'll notice, and normally when I do this, I actually have fabric samples so people get like the full experience. But instead, I'll just like flop it around with the camera, and then you can see how the light catches it, and it's a lot of fun. So we have sort of this is sort of the straight weave, the square weave. You can see the edge of the fabric. And so if you actually were to look really close at the grain of the fabric, it would be like a square shape, and you see it doesn't really give. And so especially silk, you know, it's going to tear and you're going to have a lot of problems. But if I switch it on a diagonal, then suddenly, because of the way the fibers twist, you actually get this natural stretch, and it's built into the fabric. And so that's the fabric bias. And so she basically had to develop, she didn't invent the bias cut, but she's known as the queen of the bias because she developed methods for taking this into clothing. I mean, she designed amazing women's clothing, and she worked with the bias that was in the fabric, that was a quality of the fabric, in order to do really unique, really unique clothing expressions. So I can show you pictures. So like these are some dancers. So she did a lot of stuff for dancers. But here you really get a feel for the movement. And if you can imagine, you know, I don't know how many of y'all like watch Downton Abbey and stuff like that, but you know, like their clothing is very restrictive and really confined. And then if you could imagine somebody at that time, you know, busting out with something like this, they'd be like, girl, go put some clothes on, right? So this is really, you know, this is really, really like cutting edge stuff to take the fabric puns a little further. And so the interesting thing is that with fabric, so here you can also see this is another dress that she designed. And in order to, in order to express her idea, she would ultimately have to put this into some kind of a representation. So this is a pattern. This is a two-dimensional representation or blueprint. And this is an incomplete expression. You don't really get the experience of the dress from the pattern, you know, from this two-dimensional representation. In fact, I'll tell you, it's not even enough information to make the dress, because there's been a couple blogs like from this book and others that have republished V&A's patterns. And typically, you know, it's the same thing. It's like people kind of, you have to try different things. There's a lot of information. There's a lot of context missing. You know, the pattern doesn't always tell you what kind of fabric is going to work best. And the fabric that she was using at the time was, you know, manufactured a bit differently than today. There's all these different variations. So there's a lot of contextual knowledge. In addition, you don't really, you know, you don't really get the full experience, you know, the same way. Even this photograph is kind of limited, but it kind of gives you some feature. But finally, what you don't get from it is who is V&A. The fact that she was designing in, you know, this post-World War II era, like what is her history? The fact that she was a really big social reformer in France, especially for, you know, the welfare of women and how she treated her employees. None of that really is there. You know, none of that context is there. So I think that really speaks to, you know, questions about our, kind of a major question, which is who are you wearing? If we're talking about this in the context of designers, then that makes sense. Like say you're at some, I don't know, some party or people who actually care about those kinds of things. You know, then people will be like, oh yeah, Gucci, Versace, Chanel, V&A. But, you know, for most of us, we don't really think about that. We don't think about who am I wearing? Like who made the clothes that I'm wearing? If you're sitting at a desk, who made the desk? who made the chair? If you're in a public space, do you think about like who's interacted with everything that's around you? You know, we tend to just see things as things. But when it comes down to it, everything around us is people. I mean, we're surrounded by ghosts if you really think about it. And I feel like this is starting to trickle into our, you know, day-to-day sort of common sense experience, right? So we have kind of the DIY culture, we've got maker faire, farmers markets, and even science is starting to understand the interconnectedness of the world. So we have terms like symbiosis, evolution, and ancestors. Wait, Augustina, that's not a science term. You know, that's some crazy primitive mythology or something, right? Well, so the idea of ancestors comes from more traditional knowledge. And we tend to dismiss this kind of knowledge because we don't see it as provable per our superior, rigorous scientific methods, which is interesting. So traditional knowers and science knowers, I'm just using these words as kind of illustrative, are both seeking meaning or, you know, essentially asking why. But they're coming at it from different angles, right? So science is asking what, and our traditional perspective is asking who. Who am I? Who are you? Who are we? So, for example, I used to live in Hawaii when I was a kid. My dad was stationed there. And I'm not sure how many people know, like, what, in Hawaii, if I was to ask you, who is the volcano? I'm not sure. There's a bit of a delay, so I'm not going to force you guys to sit through that. But essentially, there's a Hawaiian goddess, Pele. And even a lot of people, you know, if you visit Hawaii, or, you know, a lot of people, you know, from outside, you know, have some notion of her, but she's a volcano goddess. And, you know, a scientific perspective might say, you know, Augustina, you don't actually believe there's an angry old woman living in Kilauea. Yeah, I do. I do actually believe there's an angry old woman living in Kilauea, like, you know, named Pele. So wait, hold up. You know, we got Mr. Expert Systems Knowledge, you know, extractor over here. So you really believe if you were to climb down into the crater of Kilauea that you would see this old woman named Pele sitting there? You know, to which I'd be like, well, why would I do that? That's ridiculous. It just doesn't make any sense. You know, and then we both be really frustrated because the problem is that we're asking and answering different questions. There's a mismatch. You know, I don't know if you guys have ever tried to translate anything in Google Translate, like literally. That's kind of what's happening right here, is that we're having a perspective clash, or to steal a term from Deborah Tannen, a rich point. So there's a little bit of a mismatch happening. So, so the idea is, I'm sorry, I'm like trying to, things are jumping up at me. Okay. So the idea is, what I'm trying to express here with the Pele thing is that, so my social network is who is part of my identity, right? And Mr. Expert Knowledge Extractor is asking me, like, to objectify someone in my social network who's part of my identity is the problem. And that doesn't make any sense to me. Just if I was to ask him, Mr. Expert System Knowledge Extractor, you know, to anthropomorphize something that's, you know, that he clearly is seen as an object in his, it's ridiculous and it's absurd, and that's why happy chair is happy is funny. So, so how do we make, so I think the point that I want to make is that even with our gadgets and doodads and gigas, you know, we have this idea that, I mean, volcanoes are unpredictable, awe-inspiring, and fucking scary. I don't know if I'm allowed to say that on Twitch, sorry. But, you know, it's like, even if we're taking off in an airplane, you know, there's this uncertainty around it. Or like if you've been in an earthquake or a volcano, or sorry, I just said volcano, earthquake, storm, hurricane, you know, any kind of thing where like you really feel at the mercy of the elements, or at the mercy of what's happening around you. We have a desire as humans to make meaning, that we seek meaning, we need meaning, or maybe we don't, but generally I like to think that we do. So there's a couple ways that we can make meaning out of uncertainty. And so one strategy is to internalize it. We embrace and personify, we make her part of our social network, right? And so the second way, and this is what we do in the science way of knowing, is that we conquer and control. We externalize it, taxonomize, objectify, create ontologies. You know, in this case where we have the mismatches, like Google Translate is translating Pele literally as the volcano, and then we're saying, oh, well, that must be a bot. Like, I can't add that to my social network. This doesn't make sense. And so that's what I'm arguing that we're doing with bias, is that because bias threatens our established systems of meaning-making, our meaning-making oracles, sort of the who versus what problem. You know, where our oracles are things like, stochastic gradient descent, XGBoost, runes, tea leaves, the weather report. I mean, when you think about it, who was it? There was somebody on Twitter, I can't remember her name, but she was talking about how machine learning is basically just doing some math. And so if you replace machine learning with doing some math, it kind of puts things into context. I think AI, as another colleague of mine has suggested, is a really unfortunate term, and I agree with that, because really AI is doing some math. Like, you're doing some probability. Yes, it's deep, it's complex, there's a lot there. I'm not trying to minimize that in any way, degrade it, but I think putting it in perspective, it's not about intelligence, it's about probability. You're rolling some big ass D20s or shaking up a magic 8-ball at the end of the day, and you're trying to make a prediction, which is how we as humans make survival decisions. I mean, we need bias in order to make survival decisions. And so and so things like stereotypes or whatever, they come from somewhere, and typically they represent a less accurate representation, where we'll see something unfamiliar as just sort of one thing or one big glob. And so that bias, those biases, is woven like the fabric into who we are. It's just part of our experience. In other disciplines, we might call it subjectivity. Certainly in anthropology and in art, we think about subjectivity, and we see those as being very much a part of the human experience. So the other thing I want to be clear about is that this traditional versus science is just a metaphor that I'm making. We already personify a lot in our own culture. And, the science, through terms like anthropomorphism or reification or things like that. I could totally go off on a tangent here, but I'm trying to stick to the script here. So let's get to the application, right? So how do we personify bias? Well, the first thing that, there are a few different ways to approach, like the personification of bias, or how do we bring meaning into it, internalize it, embrace it, make it part of our identity, make it part of our social, acknowledge it as part of our identity and within our social networks. Well, first is to ask, what is the data? But don't confuse this with who. Like, what I mean is, what is the modality? What is the representation, and what is the format? You can explore different forms of expression beyond the hypothesis and the rational, for example. Can you annotate beyond words? Look at V&A. She used geometry and fabric to express her idea about femininity. Stitch Fix, Spotify, they use algorithms to express ideas about femininity as well. So Stitch Fix makes clothing recommendations to women. Spotify, if they use ad targeting segments or any kind of segmentation, chances are they recognize some level of gender identity, or in their listeners, or certainly playlists or groups, like Bikini Kill and those fun bands, Queen Latifah, stuff like that, that are really artists that are speaking about the feminine experience, and that's how it's interpreted by the listener. So whether geometry, math, music, fabric, instruments, these are all tools used by people to express ideas. And so this goes into like the second way to personify bias, which is to recognize that there is no knowledge without a knower. That knowledge doesn't exist as like it's not some thing that's extracted from people and then can exist in, say, Wikipedia. That you need to have knowers tied to the knowledge. So who is the data? Not just whose data, but who is in the data, but also who is tagging and annotating, categorizing and analyzing. So experimental rejection of observer independence in the quantum world. This is a paper that was just published in plain English. A quantum experiment suggests that there's no such thing as objective reality, right? So physicists, I mean, this is in the language of physics, but it's starting to realize, what I joke, they're finally realizing what anthropologists have already known, which is that, everybody's experience is subjective, and that you have to account for that there isn't a single objective capital T truth, or whatever. I don't know, maybe there is, but then who's looking at it, kind of takes you down this interesting philosophical conundrum. And so incorporating the annotator, and so there is work for that. There's a few papers that have been published, but that's one thing that I would look at is incorporating, allowing for the possibility, instead of aggregating and averaging your annotations, think about ways that you can incorporate even different layers of annotation, or these different perspectives. And then third is to ask, who is curating the data? Who is curating the knowledge? So for example, in speech recognition, A lot of the systems now, the way that that these systems are trained for speech recognition is that you have these databases of disembodied voices, and then these disembodied voices are then annotated or trained, or they're associated with some meaning. So you might have like 7, some sound sample of somebody saying 7, which doesn't really make sense because that's not how we experience speech, right? Like if you were walking down the street and you heard like 7, you'd be a little freaked out, like this just doesn't make any sense. It's just so out of context. And so the way that these systems work is that they'll then take that, they'll turn it into using Fourier transforms and all kinds of fancy math. They turn it into a numerical representation so that the deep learning system can do its magic, dot products and give us our prediction on the likelihood that somebody said the number 7. But these systems don't incorporate who is speaking and who is listening, which is really vital because language is human identity. It's so intertwined. And what about accents? So, for example, non-native English speakers, I'll ask, and again, there's delay, so I won't actually get to see your responses in a timely manner. So what is your experience with speech recognition systems? Can you use them? And another question to kind of take it to the social level, how do native English speakers perceive your intellectual capabilities when you interact with them? Do they talk to you like you have a PhD in astrophysics, or do they talk to you like you're a child? Do they basically talk to you like you're dumb because there's a perception that you don't speak the language properly? And so, this kind of goes into, kind of with native English speakers as well, that some native English speakers that have certain accents are also associated, have different experiences. I mean, look at Southern dialects, especially Ebonics. These tend to be associated with incorrect language usage, slang. And you can also say like, even within a Southern accent, you've got like the Kevin Spacey character Southern accent versus like Gucci Mane, right? And so these are very different perspectives, even within the same accent. And so even in my own life, like I worked really hard to not have a drawl when I was growing up. and it's something that it keeps coming back and biting me, man. I think I've finally just given in and just given up. But it basically, doors can be closed to you based on your accent because of how people perceive you. And it's really powerful. So, and these are things that are not accounted for in these speech recognition systems. So what's the difference between a language, a dialect, and incorrect usage? Well, in linguistics, we talk about, there's 75% mutual comprehension, and that's what defines it. But again, this is taking the people out of it. So for instance, Portuguese and Spanish are technically within that 75% mutual comprehension. But then there's this question of, so then is Portuguese a dialect of Spanish, or is Spanish a dialect of Portuguese? Like I know my esteemed colleague, Gabriela de Queiroz, who's from Brazil, would definitely have some opinions about that. In my family of Spanish speakers would have opinions as well. So I'm just saying, it's complicated. It's not as simple as a quantitative number. Language isn't just phonemes and syntax and semantics, but it's also identity. In language, we shape our worldview, and our worldview is also shaped by it. So, okay, so that doesn't really answer the dialect and language question. The answer is, well, it's complicated. So it depends on the people that are speaking. What about incorrect usage versus dialect? Well, I have like some really good examples of this. I have this theory about incorrect usage in dialect, and I believe that if you have a comedian making fun of the way a group of people speak, then it's probably a dialect. And I don't know if you guys can hear this or not.
I don't think there's a Y in Jack.
This is George Lopez. And so he's making a joke about Yumbo Yak. Like he has this whole skit about Yak in the Box, right? But this is my family. This is what I grew up hearing, right? And so there's a comedian making fun of the way my family talks, and other people are laughing at it. That sounds to me like it's probably a dialect. I'm just gonna say, like maybe it's not incorrect use. Now the other part is like, what about why do I only have to speak one language? I mean, I personally do because I'm not a native Spanish speaker, but like in my family, there's something called code switching that happens a lot when you have native speakers that are bilingually native or multilingually native. Is that you switch, or more colloquially, it'll be Spanish. And so here's another. I went to the store to buy those zapatos de Nike, pero estaban acá.
Los shoes amarillos, sí, estaban todos sold out.
So again, and then this is a phenomenon where you say, well, they just don't know how to speak one or the other well. But again, so the question is, so then is it trained, or is my speech recognition system, should it just be trained on one language? And if I only train it on one language, who am I excluding, and what worldviews are failing to be represented? So, and this really speaks to the final question here of this perspective, which is, what is correct language? And what we're really asking is, what is correct knowledge? Who gets to decide what the correct knowledge is for a particular thing? And so again, this is really getting to the heart of what I think is the real issue with bias. And then to wrap up, I'm not sure how I'm doing with time because we got started late, so I'm just gonna roll. Okay, I'm just gonna keep rolling. I'm just trying to be mindful. So kind of getting to the end here anyways, but so kind of the last big thing that I wanted to focus on, a lot of people who are aware of bias in machine learning and bias in AI, I'm talking about very specific applications here and very specific examples, but there's like a really big, kind of looking at the bigger social impacts. I would argue that maybe bias isn't because of a broken system, or the way that we speak about bias is it's not a bug, and it's not because the system is broken. It's because we're building systems to do things that they can't do and they shouldn't do, right? So for example, I mentioned before, I have ADHD. So I have to work with the way my brain works. I can fight it. I can do a bullet point format presentation, and then I spend a whole lot of energy trying to stay on track, trying to keep my bullet points, trying to keep all my ducks in a row. And then you only get to really, but then I'm not really immersing myself in the presentation. I'm not really able to get into it and really connect with all y'all, which is, why you watch people give presentations, I hope. And there's some level of entertainment. So what happens for me, what I found that I started experimenting with is, you'll notice I didn't really I'm kind of all over the place, right? But I feel like there's some kind of a coherent story here, at least to me, is I'm calling this the berry picking format, because there's a really great paper published. I think it was in the 90s. There was this amazing librarian out in, I think she was the University of Washington, but I could be confused. But anyway, it was this user interface, information gathering, search interface gathering theory, and that it's not that we have these objectives, linear paths, but that we tend to, go to the berry patch. We're kind of into this berry patch, and we just kind of hop around. It's like, ooh, shiny, another berry patch. So that's essentially like how my brain works. So I'm like, well, then why don't I try to do a presentation style that matches that? Because, that's what works for me. And then I'm not struggling as much. Well, I would say with these systems, these bias, the systems where we're having problems with bias, and what we're trying to apply some of these things to, is that it's kind of the same thing. We're asking them to do things that they're not good at, that they shouldn't be good at, that humans are good at. So for example, courts and corrections departments around the US are using algorithms to determine a defendant's risk, and using these kinds of algorithms. And this is active right now. This is a really big deal. And I wish people were talking about it more and more pissed off about it. But they're using these really half-assed broken algorithms for bail sentencing and parole recommendations. So it's the probability, they're looking at the probability that an individual will commit another crime, the likelihood that a defendant will show up for their court date, so they'll even give them the opportunity to post bail, right? And then there's things like, where should we deploy more patrol cars, stuff like that. And the thing that these systems completely ignore, and so where the bias problem comes in, I think, and this is a really big deal, is that they're reflecting the socioeconomic inequality and the systemic racism in our systems and in our society. And so the way that people are trying to approach these problems, this bias problem, is algorithmic. They're saying, in my opinion, it's like, oh, we have to tweak the algorithm, or we have to weight the probabilities, or, we need different data, or all these kinds of things. I'm arguing that these are obscuring the social injustice, that bias in this case is reflecting the racism that's so deeply embedded in our justice system and in our community, that if we try to obscure it, if we try to de-bias these systems, that we're really only creating a gated community Disneyland illusion. So like in tech and D&I, diversity and inclusion, we tend to hyper-focus on language. And I think that this is powerful, as I've just illustrated, that language is very tied into our worldview. But I still, that the problem is this means we ignore the racism and pretend it doesn't exist. So we're still asking for conformity to one standard worldview, or whitewashing, as I would argue it. I mean, think about what fairness can mean in this case, right? So fairness, we try to think of it as a balance, as justice. But fair can also mean blonde hair, blue-eyed reality, right? So whitewashing and just creating like a single, monocultural reality. And so that's just another way of kind of thinking about these approaches, these really simple algorithmic approaches that don't consider the larger context that these systems are existing in. So what if instead of making recommendations, what if we could use the bias as a baseline for gauging the impact of social reform efforts? What if instead of predictions that tell us answers, we have predictions that check our scope? Is there something that we might have missed? Because you can't always have a crazy person like me with ADHD working on your research team. That's going to see every stupid thing. Or imagine, and even I miss things too. I mean, I don't always sleep very well. That's a thing. But, something that we assume and that we're not asking ourselves. We use it as a tool for reflections, for what is so internalized, for that which we have so familiarized and taken for granted in our own experiences that we don't even see it, like racism. So the bias problem, so now I'm wrapping up, this is the end. The bias problem really isn't a problem with the correctness of the data or with the bias itself. I believe the solution is recognition of other forms of knowledge and inquiry. In science, data science, and AI, that we must include the subject matter expertise from a variety of knowers, such as artists, anthropologists, and even Native Indigenous communities, and just, any other perspectives that are simply not being accounted for from like this tradition of expert system knowledge extraction. That's it. That's all I got. Oh yeah, okay, cool. Yeah, feel free to tweet at me if you would like to engage in further discussion or debate.
Hey everyone, it's Amara Graham again. Thank you so much for joining into our stream at any point of the day. Maybe you just caught the last half, maybe you just caught the first half, maybe you're watching this, sometime in the future, but I really appreciate it. And I just wanted to reiterate that we pulled this off in a week, in exactly 5 business days. So everything that you saw here, my cat is sneezing in the background now, great. Everything that you saw here today was a team effort. So I can give myself credit for coming up with the idea on Friday, but I have a huge team of people that I need to thank. Again, going back to my newsroom handwritten notes here. First off, I want to thank each of our streamers today. So we started the day with Maddie and Jody. We had Megan, Gabriella, Svetlana. We had Jody again, Mary, Helen, Maureen, Shasruthi, Augustina. They were all fantastic, and they all told us a little bit about what they did, the projects that they're working on. That's, of course, one component of what they're doing. They're doing a ton of other things too, because as you may have picked up on, developer advocates wear a lot of different hats. Some other folks that I wanted to make sure that I thank, I know many of them are not listening because they're either not online or they've already gone to sleep. But Jason Kennedy was a huge help with amplification internally of helping me reach out to folks and get people on board. He did a lot of the internal logistics, and I thank him for that immensely. We also had 2 producers today. So we started this morning with one and then switched to another, which is why you may have noticed that the stream kind of dropped at one point. That was totally on purpose. So big thanks to Mike and Mia for helping us produce and direct today. Without them, we wouldn't have had a stream easy as that. We also would have had a lot of dead computers, because I don't know if you've ever tried to stream before. It takes a lot of resources from your poor computer. Next up, I wanted to thank our moderators and the group of people I just called our allies. So it was folks that, helped with amplification, getting folks on, rallying the troops, as I like to say. Big shout out here to Joe Seppi, Alex Tarpinian, Greg Gorman. I'm pretty sure none of them are listening right now either, but I wanted to thank them because, again, without them, I could not have gotten volunteers to come on the stream, because it does take a little bit convincing, and it's kind of intimidating to go out on the internet and talk and not, have the power of editing and redoing and re-saying things over and over again. Totally get it. More thank yous. Thank you to Spencer and Gina for the blog and amplification through that way. You hear me saying amplification a lot. I need a lot of help. I can't do it by myself. I can't get it out there on the internet myself. And then I guess kind of lastly, kind of in a joking way, but also not, I wanted to thank my entire management chain for letting me just run rampant over the internet. A lot of people like to say that I'm all over the internet. They see me blogging, they see me writing things. I absolutely am, because I want to try to be where the developers are, and I want to be in spaces where if you're writing code, you're already there. You don't have to go out and search for the stuff that I'm building and writing, because you already do a lot. And if I can help you, get through that next little thing, or solve that one problem that you're beating your head on your desk, I want to do that. So yeah, huge shout out to all my managers who let me do things like this and support me in doing things like this, because this week has been crazy. And then lastly, I just want to say that I love showcasing people, and I love giving credit where credit is due. So I basically reached out to all these women and said, talk about something that you're working on. I didn't meet with them. I didn't give them scripts. I didn't say, here, talk about this because it's the latest, greatest thing to talk about. I wasn't oh my gosh, SEO and marketing, this will get all the fans. No, I just said, please come and talk about projects that you're working on, things that you're doing. And I'm so excited that they stepped up for that. And I guess lastly, I keep saying lastly because I'm tired. I just also want to say that I really appreciate everybody who joined us in the chat and was very respectful and made this a safe place today. I love the internet. My job kind of relies on the internet so that I don't have to literally fly everywhere. So it was really cool to see everyone step up and make this a safe space for brand new streamers today, because like I mentioned, a lot of the women that you saw today were first-time streamers. They had never done this before. They have done, they've spoken in front of groups of people, but it's a little bit different when you're just kind of live and on the internet. So with that, I'm going to head out. Happy Friday, and enjoy the rest of your evening or afternoon. Thank you.